Before we get started, do you guys want to do like a quick round, introduce yourself, talk about what you're working on, why you're on this panel?
Sure. I'm Trent McConaughy. Spent 20 years doing AI, and then for the last 5 years been full-time in blockchain. And my main focus is Ocean Protocol, which is essentially decentralizing AI. And we've done a lot of sort of token engineering type work towards designing Ocean, and shared a lot of those thinking that probably is one of the reasons I'm on this panel, I guess. So in doing the AI work, we did a lot of AI for chip design, so building actual software tools for people designing computer chips. So I see that there's a lot of learnings from that industry that can be applied towards token engineering.
My name is PJ Leimgruber, coming to you from Los Angeles, California. So flew a very long way to get here, and I'm really excited to be here. I'm part of the District 0x team. I'm actually the marketing lead for District 0x. So one of the non-technical people you'll hear from today. Outside of District 0x, I'm also a professor at the University of Southern California. I'm currently teaching a class on digital marketing, and for the past year and a half, I've been working on building and getting approved a blockchain miner that we are in the last stages of approval for. So if everything goes according to plan, we'll be teaching and developing blockchain curriculum for university credit in the next 1 to 2 years. So I'm very excited about that.
Cool. My name's Jeff Emmett. I'm working with Giveth to build the future of giving, and that is ensuring transparent donations directly from donors to change makers, and also keeping those accountable through funding dispersed when milestones are completed by these projects. And I've also been working closely with Block Science, who is an R&D firm who is working to forward the practice of token engineering and make sure that we are rigorously designing and simulating these crypto economic models like TCRs before we deploy them into production.
Cool, thanks guys. So kind of, I think we should start with, first of all, what is a TCR, and why is it kind of taken so much of the collective attention in the like Ethereum and blockchain space in the past like year and a half or so?
I can give a quick definition. It's simply a set, and it's a pattern, just like the idea in computer science of software design patterns. And I think it happened to be a sufficiently simple pattern that's easy for people to conceptualize and deploy, and had some nice mechanics for joining this list and exiting the list and so on that kind of made sense. We'll probably get into there's probably flaws too, but overall it's simply a set, and there's lots of variants.
To give a very simple explanation, think of TCR as a curated list, right? So think about a list you would go to on TripAdvisor that has a list of very popular restaurants, right? In a TCR model, a collective group of people would control that list and say, we believe for either objective or subjective reasons why this restaurant should or should not be listed on this list, right? And the goal of a TCR is to incentivize participation for the participants to challenge applications for restaurants, in this case, to be on this list, to say, yes, I believe this restaurant should be on here, or no, they shouldn't. So if you Google TCRs, we have a video, an animated video that I spent a very long time making about what is a TCR. So if you want to get caught up on that, it's a great resource.
Yeah, I think list making is a very important aspect of humans and how we organize informations. And as we move into decentralized organizations, we need decentralized structures for curating and organizing that information so that we can determine the most important priorities to work on.
Cool. Yeah, it seems like the idea of curating a set, as you say, is kind of valuable in a lot of various different applications and a wide range of different use cases. I'm wondering, based on that like criteria, is it just a set that we can apply the pattern, the design pattern of a TCR for, or are there other data structures that also make sense to follow the same pattern and apply these same concepts to?
Well, I think there's a few. Overall, yes, there's a lot of potential patterns, and we've seen more emerging. And if you look at the history of patterns in software engineering, they started emerging in the mid-90s as a wiki. In fact, one of the people who invented the wiki started populating this list called the Philadelphia repository, basically. And in there was very simple patterns like abstract, factory, and many others basically. And over time, they evolved and evolved and evolved to end up as a book and sort of unlock this overall field of software engineering. I see that TCRs are one of the very first patterns that are well-defined, that are practical and usable in the world of designing tokenized ecosystems. And people have been deploying them. There are several TCRs that are live, and they haven't failed miserably. In fact, seem to be doing fairly well, which is promising, right? And then that's a lot different compared to say a year and a half ago when it was still sort of theory and ideas. There are other things. Probably the most closely related one. Well, there's a few variants of TCRs with actually orders in the list or grouping together a few of them to layer them and so on. And they each have their own use cases. And beyond that, you go into bonding curves, and all of that is really about curation of some different data structures. Beyond that, you have building blocks for governance, you have third-party arbitration, et cetera, et cetera. So it's a really great start, though, for this overall sort of set of building blocks that we can use and reuse in crypto.
Anybody else?
I think they can be used also as important signaling mechanisms, not necessarily ordering discrete lists, sets on a list, but signaling mechanisms for how we can aggregate the collective preference of society and determine sort of how we can make headway against these intractable kind of supranational global problems, climate change or any other global issue.
Cool. Yeah. And some of these are launched experiments. There's TCRs in production, and we've been able to examine how they're operating, how people are using them, how they're interacting. Have we learned anything from these experiments that are informing currently in progress designs? If we're applying this to our own projects, what are the things that we can learn from the people that have already pushed these to production?
I'm happy to take this first, but I don't want to always be first, so maybe I'll defer to someone else.
Well, I think a common thing that detracts from TCRs is are we creating an echo chamber, right? If the goal is to seek out subjectivity of what the best X, Y, or Z item is, but the community of people that are doing that are all part of the same community, are we really truly arriving at an answer that's subjective? And I think creating structures and creating TCRs and getting people, getting something that has a wide enough reach and a wide enough scope that will, get a population or a sample size that's large enough to achieve subjectivity, I don't think we've done that yet in TCRs.
Okay.
Yeah, I think that's, minimum economy size for a working TCR, where again, a lot of this is trial and error, and failure is learning in an experimental space like this. So I think it's important that there are all these projects that are forging ahead and experimenting wildly. And I think that we'll see successes, we'll see failures, and all of it's important to the learning process. And I'm excited about the the kind of burgeoning token engineering movement, which Trent is a big part of, and block science as well, in kind of synthesizing those failures into new models that we can experiment with in the future.
Yeah, kind of my view seeing is, are there examples of failures out there? And a way of reframing this question is, how do you verify a tokenized ecosystem? And then, one way to verify it is just to not simulate or not verify at all and just to launch it and watch it fail, right? But there's actually other ways. You can do just simple, like talking over beers with friends, or sending your white paper to design and seeing them thrash it and kill it and then try to improve. And that's actually really useful. Call it human simulation, if you will, right? And then there's software-based simulation, which is like the block sciences guys and others are doing a very nice job on. It's a very nascent field, but it's getting going. And then the third way is economic, where it's actually having real stake in the game and using blockchains as bug bounty systems. If an issue is there, then people will find it and exploit it. And this is actually exactly what happened with AdChain in its early days. And that's really great because the AdChain guys could address it. But ideally, you don't have to lose too much skin in the game with deploying live before you actually try some of the other techniques first. So in our case, in building Ocean, in the white paper initially, we had a TCR for sort of this global registry of good actors. But then from feedback from several people, they said, will this really scale to a community of 10,000, 100,000 people, right? And the answer is no, right? At least not a flat TCR. There's going to be diminishing returns for every single person that enters. So after you get past 100 or 1,000 people, are they really is it really worth taking the risk to have person number 1001, right? And that's a real problem. The other problem that I saw, and this is once again simply from human simulation, they're very gatekeepery, right? And here in blockchain land, we are trying to remove gates and lower the threshold and not have permissions where we can. So to actually try to signal that you care, you have to do largely off-chain signaling in order to say that you're good enough to join this on-chain registry. And so these are a couple problems that baseline TCRs have. There are several proposed solutions, et cetera, around. But this is the sort of thing that you can find just with human simulation even, right? Without even needing to go to software simulation or to economic-based.
Yeah, really, really fascinating. There's a couple of things to unpack there. Scalability of this mechanism is a really big question, and in my mind, kind of an unknown question, both in the entire blockchain space, but specifically for TCRs. Is this something that we can envision actually reaching like large-scale adoption? How do people interact with these things? What needs to change in order for that to scale?
That's a great question. So at District 0x, we're building a TCR called Meme Factory. And at least the hypothesis is that by creating a TCR for deciding which meme should be allowed into a meme marketplace, we can effectively start to curate the dankest memes, if you will. The thought, and at least the hope of, I think, of any crypto project is that it breaks out of the community and it goes into the mainstream. And CryptoKitties had that success. And at least our hypothesis is there's so many memes are so commonplace on the internet, and they're all over Reddit. And if we can create this system where we can definitively say these memes are new, these memes are original, and I knew about this meme early. I hopped on the train early, and Meme Factory, the TCR Meme Factory allows you to do that. So at least that's our hypothesis to achieve some sort of scale is by placing a TCR in something that everyone that's involved in the internet at least knows about.
Yeah, like make it socially scalable by making it fun, right?
Exactly, socially scalable by making it fun.
Yeah.
I think also, determining the right place for use in TCRs. I mean, TCRs are a neat way that you can decentrally curate a list, but it's a bit overkill for a shopping list. It's a bit overkill for a lot of lists that we make fairly effectively, at the level of corporations or households or whatever else. I think TCRs can provide a nice kind of like supranational structure for decision making and ordering of information and priorities. But I think there's going to be a lot of experimentation before we can get to that level for sure.
Here's a couple examples of designs to help scale. One of them is rather than if sort of a global blockchain, rather than have one sort of global TCR, you localize to the groups. So within Ocean, there's different tribes, if you will, that care. There's a group of people that really care about autonomous driving data. There's another group of people that really care about medical data for Parkinson's, et cetera. So and that group can have a set of permissions around accessing that data. So how do you curate that? It can be a TCR. Or it can be simply you get a certificate saying that you were vetted by medical authorities. So kind of how we envision entering and exiting these tribes, it's basically an Aragon DAO for governance of joining this, where the governance could simply be a TCR or some other mechanism. So that's one, basically where you push to this lower level of sort of Unix-style groups, or tribes we call them. The second one is something like a layered TCR where you have, say, 3 or 4 layers, and at the bottom layer you can have 10,000, 100,000 people in there, and there's very little skin in the game to join, maybe none at all. But then if you want to get to the higher and higher ranks, where it gets tighter and tighter in the funnel, where maybe there's only 100 people on the layer 4, there's heterogeneous rules to go from one layer to the next. And we see this for things like Wikipedia, or the C4 software process, or even things like university professors. You start off at the lowest level as a TA, you work your way up to Professor Emeritus, essentially, at the end. So a layer TCR, the bottom could easily be 10,000 people, and you're okay, right? So these are a couple ways that we see to scale. There's going to be others too, but that's at least a couple.
Cool. Yeah. Does the content of the TCR, like the specific data that you're curating, matter? I know one of the major critiques that I've seen is whether it's feasible to actually coordinate and curate subjective data, and are the applications of subjective data like going to work with a TCR, or do we need something else? Do we only need to have TCRs that curate objective data? What are you guys' thoughts on that?
I hope we disagree here. This will be fun.
So you don't want to go first.
I can if you want. No, happy to, but
I generally think that objective. So when we say objective versus subjective, right? To give you guys a very simple example, let's think about a university admissions process, right? Objective things are like, did this person graduate high school? Did this person take the right prerequisite classes? Did this person get maybe a minimum GPA or SAT score, right? These are all objective things that you can verify by looking at that person's transcript. Subjective would be things like, is this person worthy of coming to this university? You know, did they write a good enough essay? Did they do a good enough community service or do other things that are requisite for them to be admitted? So the common debate is objectivity versus subjectivity. I think objective things can be automated, and I don't necessarily know that they need a human to curate them. If you can look up these things in a database, assume that that database is trusted, then that's one less thing for the curators of the registry to have to worry about. So that I think that it should focus on subjectivity, in my opinion.
I think there's a lot to be gained if we can get subjectivity agreement on subjective measures to work. I don't think we're quite there yet. I think there's a lot of work to go into properly designing these systems and making sure that when we model them and simulate them and build them, that I think they can provide greater levels of social cohesion and coherence, but we've got a ways to go before we can know that is a robust model for sure.
So I'm actually surprised because I've heard usually people say it's either both or it's just objective. So it's awesome to hear that you're saying just subjective. Cool. I'm going to argue both, and for different reasons. I think at the heart of any sort of group of people in a society, you have laws which are you have the baseline laws that are written down, very precise, and you can have common law on top of that. But then besides that, society still functions even though sometimes there's not anything written down or no case law before it. And that's because we have social norms. And social norms are basically agreements among people in a community to act in a certain way, right? And if you violate those social norms, even if it's not written down, if you violate them, the community is going to have some retribution against you somehow, right? You might get kicked out of the community or something. This maps to TCRs. Basically, the laws are the objective ones, and the social norms are the subjective ones. So, and it might be for the objective ones, maybe you use the TCR as a sort of a fast means to quickly assess something, and then if it takes, at the end of the day, third-party arbitration or some other way that's slower, great. But at least there's costly signaling up front. For the subjective, it's directly that, because it's the community that is on the TCR, it's their belief in whatever they think is correct. But for this reason, especially for the subjective TCRs, it is critical that you see that community with the values that you want, because if you don't, you could end up with chaos, right? As we've seen with, for example, when Spore got launched, right? Within weeks, we had a whole bunch of not safe for work sort of 3D artifacts bouncing around in the Spore world. My daughter's in the audience, my 6-year-old daughter, so so is Gabby here? There we go. Hi, Gabby.
So the kind of building on the subjective versus objective question, because I know both you have been really involved in the token engineering space and trying to simulate and validate these things before we put them out in the world. Does the subjective nature of these things make it more difficult to simulate and validate these things without just saying, here it is, try and break it?
I can answer that. So, in fact, I was inspired. At first, I thought it's impossible because how do you model a human, right? And that would take an AI, and then everything else changes, like a general purpose API, etc. So then it's how do you do this? And it was actually Zargum who taught me a way. And the answer is a blockchain is moving through a state space. So let's say you have X1, X2, X3, and if you have a value for all three of those, that's the state of the system at the time. And as transactions are done on the blockchain, it's evolving through that space. Now, of course, we don't just have 3 dimensions, we have thousands, right? And then the question is, what does it take to transition from one state to the next? And this is basically what actions are allowed on the blockchain itself, right? So you can actually bound to this, right, with defining what's allowed. And then what you need to do is you need to say, what is the worst case possible things that could happen? Not the probabilistic case, the worst case. The probabilistic does need modeling humans and all this. You need the worst case. And this is what we did in circuit design. You say, a circuit needs to work across all possible temperatures, all possible power conditions, et cetera, et cetera, et cetera. And then whatever the worst case performance of this, of your chip is, if it's still okay, you're good to go. That's the way that I see with this too. So there's simulation at the lowest level. One level up, you have verification. And we need verification in a worst case setting according to this bounding the state space like Zargham described. And then we're good to go.
But isn't the worst case in a subjective like model of a human somebody that's completely irrational?
So you still need to have assumptions in the model, saying, for example, like if the worst case is that you have more than 51% of the actors or 25% or whatever, then you're completely screwed, right? So you have to say, okay, I'm going to assume that no matter what, there's a few fundamental things that don't get violated, and then beyond that, you have to go worst case. Maybe I think it's going to be pretty pessimistic at first. So I hope over time we can get to models and verification that's much more probabilistic based, but it's going to take a lot of time.
Also, when you come at it from the irrational actor, you have irrational actors acting in multiple directions, which kind of balances out to just a general noise in the system. So you can also model in noise that can reflect the action of multiple irrational behaviors acting in different ways. So it is, in some way, can be built into the model that you can predict along with that behavior as well.
Yeah, and to sort of underscore, right, like a key thing here is if you assume that there's this list of possible actions that happen, you're not saying you're following some particular set of types of actors like, rational or good or otherwise. It's simply, this is all possible sets of cases, right? It could be 100% irrational and you're okay.
And I think just to add on to that, this is something that I've been speaking with Zargham at Block Science, and just kind of a different way to look at social signals, and I believe he has some electrical engineering background. I believe Trent does as well. I do myself, and using error correcting codes. So when we send signals in electronics, we have error correcting codes that we want to make sure there wasn't packets lost in between. So we have kind of these signals that ensure coherent message. And we've been talking about potentially applying error correcting codes in social signals coming from TCRs or curation markets to try and determine, a coherent social signal, which would be a really interesting field of research, I think.
That's super cool.
Mm-hmm.
Yeah, really cool. We're running low on time. I want to cover this one last topic that's really interesting. I want to hear your opinions on alternative structures for TCRs to allow ranked lists. Like the canonical example is typically like a whitelist or a blacklist of entries. You're either on the list or you're off the list. But there's certain types of applications where you need to actually know the order of the list. And I'm curious what your thoughts are, if you've put in any thought into like what variations on this model can allow for ordered sets.
Sorry, go ahead.
Well, I think ordered sets get very, very interesting to potentially for businesses. Like if we were to look at a Yelp, right? A Yelp is an ordered list of restaurants in a different category, the best Mexican restaurant or the best seafood restaurant. For those business owners, there's substantial financial outcome for them to be top on the list. Same thing with being top for a search result on Google. So I think when you apply that, there's value in being on a list and value in being included in a list. And I think people that curate the list would want their list to be seen as valuable. So I think under those assumptions, yeah, I do think that there would be ways to curate a list where ranked order is very, very important. I don't necessarily know that that's the biggest problem facing TCRs, but I do think there are scenarios where the ranks are extremely important.
Another type of TCR that I've been discussing with Block Science that I'm pretty excited about is something we're calling conviction voting, which is kind of a continuous preference broadcast. Rather than having a vote that occurs on Wednesday, for a 72-hour period, you are continuously broadcasting your preference for everything in the list at any given time. And this is much more biomimetic. It's designing as nature. When decisions happen in nature, it doesn't happen on a Wednesday. It happens continuously. So this would be an interesting another area of research that to see if we can make that work.
Yeah, there's out there in the world of the blockchain literature, i.e. Medium, Sebastian Gadjek wrote an article called Graded TCRs. That was quite a nice approach to this. And then kind of more broadly in the sort of set of just space of TCRs, Matt Lockyer wrote a blog post that sort of synthesized about 6 or 7 of these different patterns. So graded TCRs, layered TCRs, sort of trees of them nested. And there's a way to generalize all of this too, to where you're basically going from one set of actors to another, and it could be in a DAG. And that's what Dimitri de Jong kind of invented a couple years ago, what he calls stake machines. So S-T-A-K-E, not to be confused with S-T-E-A-K, because there is that one as well.
Too.
Yeah, there is that one too. So anyway, that's stake machines, and that's a generalized way, sort of, moving from one group of individuals to another via this DAG, right? So I think there's quite a few, and you don't have to rely on TCR as well. For example, if every single actor had its own bonding curve attached to it, then you can rank simply to how much liquidity is tied up in each bonding curve. So there's a lot of other options beyond the sort of classical TCR type way of thinking.
Cool. I think we're pretty much out of time, so I don't think we have enough time for another question. But thank you guys so much. That was enlightening.
Thank you.
We could talk all day.
Happy to. Thank you.
Thank you.